Hi, my name is Professor Art Langer from Northeastern University. I'm an Associate Vice Provost, Professor in the Business School, and the Director of the Center for Technology Management and Digital Leadership. I'm also affiliated for some time with Columbia University School of Education Teachers College in the Department of Organization and Leadership. And I'm delighted to open up the conference here as a keynote on the analysis and design of the next generation software architecture book that I published, which focuses mainly on architectural issues of 5, 6G, IoT, blockchain, and quantum computing. So I'm going to get started, and I hope you enjoy a provocative presentation today. So let's start by creating a roadmap, right? We always like roadmaps of the next generation issues. And I'm going to start with the impact of enhanced speed of mobile devices that really came from 5G, and as we'll talk about 6G, which is coming in my new edition, which is creating the data, creating access to massive amounts of data. That in turn makes IoT much more reliable and practical and necessary. So it creates the repository where that collection is occurring from the speed in mobility. This is a key. So that in turn creates an explosion of IoT devices that are going on today and will increase over time, and ultimately establishes a dramatic increase in the amount of data that we have available, which is the key that is generating this need for the next generation of architecture. And then we have this, what we call a little fork in the road. It goes into two different directions. One, simply put, mobile devices get a lot smarter, all right? Because we have a lot more data, we have applications that can be downloaded. Again, going back to the 5G, 6G speed capability, that makes it more practical. And that better device I/O establishes all of the data capture and activities that are going on through the mobile network. So yes, it is the mobility factors that are really pushing us towards the next generation. But before we go on, let's go to the security exposure here. All right. So by getting all that extra data, we're also dealing with much more security exposure, which brings us down to a new way of processing that data to protect it. And that is the new blockchain type processors that are out there. I'm going to talk more about this. All right. But blockchain provides a new way of security. It's not foolproof. It'll improve, and maybe there'll be different names. But that establishes the fact that blockchain has latency issues. All right. With all of those advantages, it's slower. So that's what puts us to the fact that it has to be the end of silicon as we know it. We need to forge forward. Quantum seems to be the big issue. That's what we'll be discussing. Now, what also happens is that fork in the road that we had, the better device I/O, the end of silicon as we know it, really meets together with the capability of explosion of AI, artificial intelligence, machine learning, new applications, cloud. So everything we're going to discuss is we're going to talk about these roadmap issues and why it is so important to get started now, because 6G is supposedly coming in the early parts of 2030, which is really not all that far away. So what are the next generation challenges? Movement to platform design. And we'll talk a little bit about the notion of proliferation of mini applications that allow the consumer to put things into different perspectives and personalize it. Those mini apps will need to replicate data. And that's a sort of new thing, right? Because we've been brought up where our computer systems have the data in one place where they can protect it. So re-architecture now gets involved with the movement to cloud, and that becomes a key other component to everything that's going on. It is, in many ways, the end of relational databases as we know them. It is not the elimination of it, but it plays a different role. The decomposition of existing large legacy application to be decomposed down to mini applications. That'll require legacy links, right? Because we can't convert everything all at once. Temporary bridges that allow the new architecture and the old architecture to operate together. The insert of block engines. Think of a car and you change the engine and you put it in and you connect all of these bridges. That's what you're looking at as we go forward in that journey. And then ultimately the coming of 6G and its dramatic impact on artificial intelligence. So stay tuned as we go forward here. We're going to address each of these issues. So it all comes down to the impact of big data, right? What we used to call big data, proliferation of that data, and ultimately it's a revolution that is forcing our clientele, our organizations, to become more data-centric, more dependable on the data. The data is generating things as opposed to necessarily processes. This revolution relates to the substantial increases in available data and the impact of advanced AI capabilities. Those two come together. But remember, let's go back to that mobility factor. The collection of the data is generating all of that new information that's coming through the system. So what are the facts to consider here? Well, one, increases in wireless performance and speed will exponentially reach billions of people. Not millions, but billions. 6G is expected in early 2030s and will be 100 times faster than 5G. 6G will have embedded AI and be ubiquitous. We'll talk more about that very shortly. The amount of data collected over the next 3 years alone will likely surpass the amount of data collected during the postmodern era. Think of the volumes of different types of data. AI will affect every aspect of personal and economic life. What I'm saying to you here is your personal life, your economic life, your business life, it's all coming together eclectically in each other. Quantum and new architectures will be developed, all right, because customers will demand it and will augment in many ways the mobile communication capability on top of the classical internet model. There will be more data devices than the global population. Many of us have 2, 3 pieces of equipment, and as developing nations tend to increase, you should see some of the predictions of the pull on mobile data that's coming through. Now, let's talk about this data centricity a little bit more. The digital data-centric product development that I've been talking about. On the left-hand side, you see a whole bunch of colored parts. And this is what I call the Lego scenario, right? Or the Lego example. The famous toy company that for decades created little parts to put together specific output things like cars and Erectoset type things. So kids bought it and they built it and put it together. Somewhere along the line, Lego figured out that if they just sold the parts, that their consumers would become creative. And on the right-hand side, you see here, each of those colors creating a unique product. And that's exactly what's happened. All right. So you actually go to the store or order Lego parts, and the consumer participates in the development of new applications by putting together new renditions creatively. So what this all represents is, can you create an infrastructure that gives you that? And the answer is yes. Now, there's many other words we've been using in the digital products area. We call it hyper-automation capabilities, high scalability. We have to use hybrid cloud capabilities to provide not only the data, but also the Lego parts. It's all focused on a customer experience. When you look at all the digital companies, that's what they're giving you. And they deliver it in high velocity. And let's face it, when you buy a smartphone, what's the first thing you do? You personalize it, right? So the architecture allows you to do that. But how many industrial size architectures can support that? All right, especially with what is coming. So as you could see, we've got a lot of work to do. So let's talk a little bit more about 6G and wireless, because in many ways, it's going to deliver many of the things that 5G couldn't for various reasons, which I will point out. While 5G mobile networks and system clearly provided positive next generation global telecommunication, they more importantly represent profound evolution of home, machine-to-machine industrial communication capabilities. Remember, I said to you that this stuff is coming together. These new performance capacities have allowed for major advancements in the way we utilize artificial intelligence, driven by machine learning, and in general, how we learn and interact with every part of our lives. 5G was the initiator of next generations of systems architecture, but has not proficiently maximized that impact on the commercial world, particularly in architectural design. This new architecture will be enhanced much more with the coming of 6G, now forecasted to have an impact very much on industry. While 6G, 5G opened the door for AI exploration, it is 6G, which is due around 2030, probably a little bit later, will have AI embedded in a self-contained service. The International Telecommunication Union, ITU, has reported that as of 2022, there were more than 8.5 billion mobile subscriptions. This compares to a global population of only 7.95 billion, suggesting that there are now more mobile phones than people. Given that many parts of the world have limited physical network infrastructure, enhanced mobile communication represents the only viable approach to linking networks of data and applications. So 6G is expected to fuel the new economies of the future and be driven by sophisticated mobile communications. Ultimately, 6G is the enabler that will allow for specialized networks to participate in what I call global systems integration, true global systems integration of seamless components. It also represents the scalability of networks that can be dynamically linked and integrated across consumers, communities, corporations, and government entities, and driven by embedded AI capabilities. So all these Lego parts are mini apps. This is going to start to create the infrastructure architecture to make it all work. This integration allows these multiple systems to communicate through a common platform. There's that word again, which will service all aspects of an individual's life in almost real-time reality. As with most emerging wireless inventions, 5G met with a number of challenges and certainly disappointments. One, it was hard to install and deploy. The transmitters were needed to cover the same area as 4G. And as one could expect, COVID-19 really put a dent into the proliferation of the sensors, the transmitters, and certainly added more cost to deploy it and slowed it down. 5G is shown to be very exposed to hackers, malware, third-party breachers. And furthermore, once a breach has occurred, malware has been able to spread throughout a carrier's infrastructure and network devices. That's why in my earlier chart, where we began this journey, all right, we talked about how cyber comes along as an important component to address. According to a study performed by Del Oro Group, only 39 big mobile operators have deployed the newer standalone SA version of 5G. It's known as the real 5G because of those delays. And that version has been coined as that real 5G, the slow deployment among carriers, because only 200 non-standalone networks have really put it into place. Overall, 5G requires much more infrastructure and has signal challenges that have taken longer to address and deploy. It's part of the development of this technology and capability. 6G is designed to bring many new things, and it's being referred to as a seamless reality that depicts joining of the physical and digital worlds. Specifically, it provides more human friendliness to the end user and addresses important infrastructure features such as self-contained ecosystem of AI that it commoditized in there, near instant and unrestricted wireless communication, intelligent connected management and control functions, reduced energy footprint, global standards very much needed, AI as a service, which I mentioned before. So as soon as you get onto any of these systems, AI will be available. The objective then of 6G is to achieve that merged reality, especially of the future where individuals and groups can meet and interact in new ways of human experience that include faraway places and among different cultures. It is set to become the holodeck from the Star Trek movies, in that virtual reality will be mixed and integrated with the real human interfaces. The hope then is that 6G will help establish more user-friendly or human-friendly and efficient society using advanced communications and software. The impact of ubiquitous operations, remember I mentioned that, it is scheduled for release somewhere in the early 2030s, but companies need to start now to establish infrastructures to support its launch. 6G is expected to be 100 times faster than 5G, which approaches an interaction that can be categorized as instantaneous response time. This accomplishment allows for further commercialization of autonomous vehicles, augmented and virtual reality experiences, and smart cities, which have been enormously delayed in implementation. These specific capabilities include integration of everything, intelligent connected management, integrated sensing and communication, scalability and affordability, trustworthy infrastructure, AI as a service in a federated network, integration of physical worlds with Internet of Senses, which has automated decisions with zero-touch approach. This is the sensors and the agents that we're going to see proliferating. Lower latency. Overall, the promise of 6G is its impact on a number of commercial industries and cities. Drones will become much more strategic IoT devices as well, not only for high-precision robotics, but for general use as alternatives to satellite networks. Healthcare will be improved because remote surgeries will be more capable with improved safety. Financial industries will also benefit by having access to higher frequency trading platforms. 6G also brings advancement in IoT devices for smartphone applications and appliances and connected cars that rely on low latency for efficient use. This is all extremely exciting, but the back end's got to work. So what's the conclusion of this mobility journey I've taken you on? With the evolution of 6G, numerous sensors will be established across the world that will allow for updating of the digital world in near real time. This will allow analysts and designers to rely on actuators in the physical world that will automatically update requirements and code performance. This can support further use of digital twins proliferation. It will provide the intelligence via ongoing connectivity and synchronization of data to further support the emergence of Gen AI, ChatGPT, all of these things that are coming every day. Okay, we've looked at that first fork in the road. Now we want to talk about the cyber dilemma. And I'm going to start this conversation off talking about the Maginot Line, which was put together before World War II and failed to protect the French against German invasion. It was what we call a perimeter concept. We build this huge wall of defense across the border between Germany and France, and we stop the Germans from coming in. Okay? But it didn't work. And this is what cyber is today, right? What we see is you install cybersecurity software in your system. It is, in effect, the version of the Maginot Line in technology. So what ended up happening? Well, the Germans were very smart. And if you look at this chart here, this is Germany, this is France, here's the Maginot Line. Well, the Germans went around it. When with new technologies, we're able to go through the Ardennes forest. And once they got through, the French had no answer. So they were conquered very, very, very quickly. Now, let's relate this to what's going on in our world. Most cybersecurity professionals will tell you can't stop being compromised. And they're right. And that's because we have an old architecture which is perimeter based. Now let's go back to the Art Langer mini apps discussion. All right, the Lego parts. Every one of those Lego parts has to have its own security. So security has to be re-architected into the development process of every application. That's a lot of work, but very powerful when it gets done. That's why I'm telling you, you need to move faster. And it wasn't always blamed for everything because there's a cost of all of this, which is necessary because there's going to be winners and losers. The laggards are going to lose in this particular world if they don't have this re-architecture. Now, the digital twin things that I discussed before, this is a complicated drawing. It's a Gartner drawing. It's in the book, and it's just the beginning of the power of sensors and digital twins. You'll see up here the simulations and conditions, but predictions is another important part, right? We're getting smart agents that are going to make decisions for us. There's analytical models of software in there, software components, metadata, and generating new data. These sensors and digital twins will generate new data, which will add to the amount of data that's coming in. Now, these most likely would come in with third-party products that you're going to have to once again integrate into your existing architecture. So we're calling this digital twin enabling technologies. And again, it's not that you have to develop it, but you have to create the connectivities just like you do in anything else engineering in the world. And then let's get back to blockchain, right? It got famous with Bitcoin. It had latency problems, but look at this chart. There's now over 50 blockchain real-world use cases in everything you can think of: energy, railways, enterprise, music, supply chains, insurance. Remember what I said, there'll be a blockchain engine for everything that will go in. That's going to be replicating data. That's going to help with cybersecurity, all right? It's going to make it much more difficult, all right? But not foolproof. But when we get into the whole area of quantum, it's going to aid it greatly as this new architecture comes into place. And what do you have to do when you drop in an engine? You're going to have to reconnect it. So you're going to buy a third-party blockchain, and maybe it'll be called something else. I expect it will be. But you could see how these parts are coming together to address the other problem of how do we protect these volumes of data that we're going to have. But then, of course, there's multi-cloud. While blockchain appears to be the new processing engine, cloud is the future data repository, also including the applications. The two must interact in a very complex way. Indeed, blockchain architecture wants to replicate data and store it, and cloud wants to somehow still maintain central control of the data with back-end relational databases. On the other hand, cloud also represents some combination of the two, since we can execute applications from the cloud in addition to that data storage. So what cloud really does is to provide a more cost-effective way to expand application across the internet. Cloud will mature into a major hosting facility that allows global businesses to thrive throughout the world, assuming, of course, that security can be assured at a higher level. Quantum. Well, it isn't, you can't buy it yet, right? But the potential perhaps is closer than you think. The essential advantage of quantum is significant processing performance because it can provide multiple answers simultaneously. In physics, we call this superposition. This capability has significant advantage when dealing with uncertainty problems. That is where we don't know the answer we're looking for. We're looking for guidance and exploratory results. Quantum allows simultaneous computations to take place, yet maintain a relationship with all the other computations that are going on simultaneously. This is called, again, in physics, entanglement, where somehow they're separate, but they're also relating to each other. So you're getting parallel processing in many ways. It provides enormous benefits with distributed large databases like IoT devices that contain multiple but related data sets. So think about all these things going on, and somehow they're entangled together, all right? And they're coming up with multiple possible answers through superposition. Interesting times. So I hope I perked your interest. I hope that you understand that the time to get ready is now. I hope you understand that it will take money and investment. I hope I've been provocative, and I appreciate the opportunity to have spoken with you. So thank you very, very much. And if you want to get in touch with me, you can get me either through art.langer@columbia.edu or a.langer@northeastern.edu. I'll be pleased to take your questions at that time.